So we looked at addition and subtraction of integers last week in terms of modeling them. We used the number line, the chip, and the charged particle model. So let's take a look at the chip model. If I can get my whiteboard to work, there we go. So let's start with addition, and then we'll do a subtraction to warm up. And so this is how to model it with chips. And by model, right, we have to get physical, and I mentioned last time with integers, they're a little bit more complicated. We got to state a couple of things. First, we have to show what does it mean to be an integer, and then we have to show what does it mean to be addition, and then we can go and do the problem. So for example, let's take a look at -3 plus 5. What is that going to look like with the chip model? To do that, I'll start off with what an integer is. And so we'll have the open one can be a negative. And we'll have the solid one for my key can be a positive. And then together, we get another representation of 0. So a reminder, there's multiple ways to represent any integer. So I could represent 0 by a set with nothing in it, or I could represent 0 by a set with an equal number of positives and negatives. So this set right here has 0 in it. This set right here has 0 in it. And this set right here has 0 in it. So each of these sets are a different representation of 0. So this is what I call my key for what it means to be an integer in order to model this. And then I need to state what does add mean. So add just means combine and count. That's pretty straightforward. So then I'll have to start off with a group of -3. And then we want to combine that with a group of 5. And so I put them together into a new group. And I like to draw these in stages, what I start with and what I end up with. So here's my new group. And then I can make a note here that there are 1, 2, 3 zeros. So then we have 2 for the final answer because of those zeros, which we could redraw if we want. But I think that second to last picture is good enough. So we have to show what we're starting with, we got to show what we're ending up with, and we have to then state what the result is. So a group of -3 combined with a group of 5 gives us a group of 2 because we have those pieces that zero out based on our key. Question on that model. All right, I hope you're all with me on this one. So that again is the addition of integers with the chip model. Let's try a subtraction for fun. So we need our problem to work with, and then we need to go about modeling it. So let's do a couple of different ones. For this one, subtraction, it's kind of a little harder to model. So suppose we had 5 minus 3. We need a key. So the key would again be what your situation is, whether you're using colors or just kind of black and white, or maybe you want to use the charges like the plus and the minus. Let's stick with the same ones. Do I have a question? Okay, speak up if you have a question. So we have our negatives. We have what a positive looks like. And sorry, that's kind of messy. And then a 0. And then what does subtraction mean? So subtraction can either mean take away or it can mean compare. And so you want to be upfront about which one you're using because the pictures do look different. So let's do take away. And so a question I could put with this to make it a little more clear is what is 5 take away 3? And so I start with my group of 5. And make sure you have the right version. These are positives, so they get shaded. And I take away 3. So maybe I'll take that one and that one and that one. So I can then make a new picture and say that leaves 2. So those 2 weren't taken away. So again, there's some similarity between what I have here, 5 minus 3, and the previous problem. This one has a positive 5 in it, and there's a kind of a minus 3 there, and the answer is 2. And this one has a 5, and there's a minus 3, and the answer is 2. But notice the models are totally different. This one I'm doing a subtraction. This one I'm doing an addition. I'm combining things, some stuff zeros out, but they're definitely related. And we'll talk about that relationship later. Questions on this one? All right, let's do another subtraction example. Excuse me. This time, let's try -3 minus -5. And again, we need a key. This is on a new page. If it's on the same page, I would just get away with one key. Negative, positive, and 0. And I don't know if you noticed, it doesn't matter the order of the positive and the negative and the positive. I'm mixing it up just for fun. But again, important to emphasize 2 together, combined together, give us a 0, that kind of cancellation. And then what does subtract mean? I'm going to go with the takeaway again. So subtract means takeaway. And so the question here would be from -3 take away, oops, -5. So how do we go about doing that? So again, just like before, we have to start with -3. So draw that set. Now, a problem I have here that I didn't before is I can't take all of -5. There's just not enough. I'm just going to put a little yet there, because I could rebuild -3 with some zeros. So I could draw -3 this way. This still has a net value of -3. So I have my -3 there, but these 2 are just zeros hanging out. But now I can take away -5. And so I just pick this one, and that one, and this one, and that one, and that one to take. And so that leaves 2. And we can draw that final 2 if we wish. Or I think it's pretty clear in this picture that those 2 are left and that they're a +2, not a -2 because of their shading. So sometimes with this modeling, we have to build up with zeros so that we can take away what we need to. Question on this one.
I'm good. Could we do a comparison one also?
Sure, let's do a comparison on this one. So we'll do the same, -3 minus -5, but this time we'll say subtract means compare. And so then we want to become clear about what is the comparison. And so here I would state how much more is -3 than -5. And so to do this one, again, I need a key because I got a new page. If this is all on one page, one key at the top would be good enough. So what does it mean to be negative here? What does it mean to be positive here? And what does it mean to be 0? To do the comparison, you have to draw both sets up front. So I have to draw -3, and then I'll just write compared to -5, and I'll draw them each underneath. So here's my set with -3 in it. Here's my set with -5. And then we want to try and match them up. So, an important thing here is matching up with the first set. So when I start matching up with the second set, I'm okay at first. But then I ran out and I haven't fully compared with -5, so I'm not done. So then what I'm going to do is I'm going to rebuild the -3. So 1, 2, 3, and then I'll throw in some zeros. So this is still -3 in this set here. The -5 can stay as it was because it had plenty to compare to. And then continue. So I had those compared and those compared, and now I'll just continue, and now I'm done comparing with the original set and the other one, and I have 2 left over. So -3 would be 2 more than -5. For a lot of problems, I find the takeaway is a little bit easier to do than the comparison with the signs. So that one is a little weird, much weirder than the takeaway version. So that's like, I think the number line's fun to do. We could look at that one again. And then we have the charged particle and the chip model, which are pretty much the same thing, just different versions of the picture, right? With the charged particle, the key just looks a little bit different, where we use the pluses and minuses. And sometimes I like that one better. that's where we just say that's a negative and that's a positive, and two of them together is a 0. And they're pretty much interchangeable besides, they're slightly different shapes that make that happen. So let's do a number line example, and then I want to talk about, so these are models, right? Pictures we draw to try and justify why there is an answer. Next, we got to look at algorithms, because I don't want to draw a picture for bigger numbers. So how do we go about getting an answer? How does the calculator do it? That's what we need to look at. One more model review, the number line model. And let's do subtraction, because it's a little more complicated. And as far as the number line model goes for subtraction, there's two rules that make it work. One is that the arrow for the number that's subtracted has to turn and face the opposite direction. But then otherwise, it's pretty much like addition. We combine the arrows end to end, or front to back. So if I wanted to demonstrate -3 minus -5, we would start with the -3 from 0, and then we use the rules to do the subtraction. So drawing my number line. And with kids, we would have number lines on the desk that they could play with, or some pre-done number line on the screen that they could play with. Kind of like in some of your homework problems where I had the number line on the screen already and you just kind of had to play around with the arrows. So then here, I would start at 0 and draw my arrow of -3. So use a different color. So 1, 2, 3. And just double check that it's the right size. Now, normally -5 would go back this way. But rule 1 says to flip that. But starting from the end of this arrow here. So my -5 has to switch the other direction, go 1, 2, 3, 4, 5, and then count, make sure you got your right distance. And then see where we end up. So that would be the number line model for subtraction. We have the extra rule, and then it just jumps to addition. So the next thing we have to come up with is, well, what's the algorithm? What are the rules? And choose a prettier color. Algorithms for addition and subtraction of integers. And I went over the algorithm for subtraction, and the algorithm was simply to just rewrite as an addition problem by adding the opposite. So the subtraction algorithm, I'll do a few examples, solves half of our problem. We just rewrite subtraction as adding the opposite. So some examples of this, if we took that previous subtraction we had, which was -3 minus -5, we would rewrite this subtraction as adding the opposite of -5, which is 5. So these two should have the same, is what the algorithm says. Earlier we had 5 minus 3, so that would be rewriting the subtraction as adding the opposite. So this subtraction and that addition problem will have the same answer. So that's the subtraction algorithm. The question is, though, well, how do you add then, right? What do these imply we should do? So we got to come up with the addition algorithm. So what do we do to calculate these additions? So what I'm going to do next is I'm going to put you guys in groups, and you're each going to have a slightly different problem. And you're going to just tell me, how do you calculate that without a calculator? So first I'm going to show you the problems, then I'll split into groups. Pause the recording and have a new one for those that aren't with us today. All right, and split this up just a little. Ooh, it doesn't blow up. I think I learned that last time. All right, so sorry, Jamboard doesn't blow. Here's the blow up button over there. Maybe. Okay, that's a little better. So I'm gonna have a group 1, and you all have the same kind of question at the top. How do you do integers, addition of integers without a calculator, but you have slightly different problems. So group 1 is gonna take -47 plus -73. And then, bottom of my way, zoom. Group 2 is gonna take -47 plus 73, and group 3 is gonna take 47 plus -73. So I just kind of played around with the signs. Each one is an addition problem. I do not want you to draw any chips or charged particles or number lines. I just want you to be a calculator and show me how to get an answer here. Okay. So we'll resume with results in just a moment in the second recording.